And mobile services are open to all four major platforms. Windows 8 for sure, Windows Phone obviously, but also iOS and Android. And they are first-class citizens in mobile services, and I hope to show this on Thursday. So it's kind of a different Microsoft. At least if you look back 5, 10 years, it's really a different Microsoft, at least as far as Windows Azure is concerned. So Node, as I said, is JavaScript on the server. It uses a super fast JavaScript engine, which is a couple of light years ahead of what browsers use, although browsers are kind of catching up. There's a JavaScript just-in-time compiler in there, which again, major browsers have also started using just-in-time compilation. There's a garbage collector that's better than what you see in most browsers, so it's really more suitable for server applications. And Node is an ecosystem. It's not just this little tiny engine that lets you run console.log and print statements, JavaScript objects to the command line. There's hundreds, if not thousands, of popular modules. Most of them, if not all, are open source. They live on GitHub mostly. There's a package manager for Node, quite similar to NuGet, where you can download packages in a single command line and update these packages. You can specify dependencies for your Node application, and if you develop packages, you can specify dependencies for them as well. So you can have just a single little file that describes all the packages your application needs, and then you can deploy it to Azure or to other hosting providers, and they will just pull the modules down for you. And you also get updates automatically as they are pushed to the package repository. And again, pretty much everything is open source. It's open for modification, forking, whatnot. And there have been some companies using Node for a couple of years now, like LinkedIn, eBay, Microsoft itself. And they have also contributed to Node and pushed packages of their own, and you can find them online. So why would you do JavaScript on the server? I mean, at least I asked myself that question because C# on the server is pretty powerful. I mean, you have ASP.NET, you have NC Framework, you have the taskbar library. So one reason for me, at least, is that Node is cross-platform. I'm using a Mac. You can see it here because of the podium, but I'm using a Mac right now. And I can run my Node applications on my Mac, test them on my Mac, debug them on my Mac, and then push them to a Linux virtual machine. Or push them to Windows Azure as a website, and then they run in a virtual machine with Windows Server 2012. So it really does just work. There's only a very small number of modules that are not cross-platform, and in fact I'm going to be using one today, which is the SQL Server Client module. That doesn't work on anything but Windows. It uses the SQL Server native client library. But for the most part, you can use Node on any platform, and you can just expect the same JavaScript to be completely cross-platform, run on every major platform that has Node support. It's also kind of cool. And if you look at Stack Overflow, the language index, all kinds of websites that measure popularity of frameworks and programming languages, you'll see Node is kind of gaining all the time, exponentially in popularity. It seems to be the next cool thing after Ruby on Rails. It's also pretty convenient for front-end developers to just kind of slide into Node development on the server, because you don't have to deal with threads, for example. Most Node applications do not use threads explicitly. Everything is asynchronous on the one end, pretty much like asynchronous AJAX calls in the browser, and you can still issue multiple asynchronous requests, like database calls, like web service requests to other web services in your system, but you don't deal with threads explicitly. You don't create threads. You don't have a thread pool that you have to increase and decrease and configure. Everything is asynchronous on the one hand, but you don't have to think about threads on the other hand. And also Node has a tiny footprint compared to, a big web server like maybe IIS. You can run Node inside IIS, and that's what Azure does when you use Azure websites. But you can also run Node using a single exe. It's about 4.5 megabytes, and that's all you need, just this one single exe, and you can run your JavaScript application on Windows, Linux, or Mac. That's the footprint of the system, and that's also probably why it's so suitable for low memory and even embedded systems like I mentioned before. I don't like JavaScript. I mean, I'm sure some of you share this sentiment. Well, it's a weird language, dynamic, but then there's so many quirks, not statically typed for the most part. And even though I'm not going to be showing you TypeScript in this talk, you really should check it out if you're thinking what I'm thinking, that JavaScript is just not so suitable for huge applications, hundreds of thousands or millions lines of code. And TypeScript is a Microsoft effort for a more statically typed JavaScript that has classes, modules, interfaces, constructors, all built into the syntax, and it compiles down to plain old JavaScript. And you can see that JavaScript. And it's cleaner JavaScript than what I would write by hand. So it's probably a good idea, at least for me, to consider moving my examples to TypeScript. But anyway, I'm going to use the plain JavaScript for this talk. And here's our first Node application. And that's kind of the typical hello world sample that you see for Node, even though you could just write a single line JavaScript application that prints hello world to the console. But this is a little more interesting because these 5 lines of code give you an HTTP server using a built-in package called HTTP, which then has a method called createServer, which takes a function which will be executed asynchronously as requests arrive. And that function takes 2 parameters, a request and a response. And they all have a bunch of properties, of course. There's a bunch of objects handing off these request and response gateways. And one thing I can do is just issue a response and completely ignore the request. So whatever request I'm getting, whatever the URL is, I'm just sending back status code 200, which is OK, content type text plain, and the text of my response is hello node. And then I'm just configuring my server to listen on a specific port. So let's see the thing actually run. I have here this hello Node.js file. And well, let me just show it's pretty similar to what I have on the slide. It's pretty similar, although not identical. It sends back a bit of HTML. And now I can just say node, hello node, and it's running. And if I go to my browser here, here's our amazing web application. Okay, so that's not very interesting. But how about, before we do anything else, how about we deploy this thing to Windows Azure? And I'm going to talk more about Azure websites and the options you have for deployment, but right now, just bear with me as we deploy this Node application to Azure websites using Dropbox. I'm just going to put this file in a Dropbox folder. Azure is going to pick it up from there, and we'll have a website available for everyone to use. So I'm going to my browser again, and this is the Windows Azure portal, which I assume many of you have seen already. And I'm just going to create a new website. It's right down here, the New button. I'm clicking New. And then I'm going to go to Custom Create here. And I'm going to name this hello VS Live node.azurewebsites.net, which happens to be available. And I'm going to choose a subscription and a region. I don't need a database. And I'm going to check this publish from source control checkbox here. And then I'm going to click Next. And it's asking me, where's my source code? And this is what publish from source control means. I have a source code repository somewhere, like Dropbox, but also maybe TFS, GitHub, Mercurial. And Azure can pull from that repository, or Azure could host a repository for me, and I will push my updates into that repository. And there's also support for deployment hooks here, which basically means you can host your repo wherever you want, maybe GitHub, maybe your own company servers. And you just need to configure your source control server to tell Windows Azure whenever you have a commit to a particular branch maybe, or a label that you want to push to the production servers or to the QA servers, and Azure is going to take that and deploy. In our case, we're going to use Dropbox. Yes?
Scroll down.
Yeah, sure. Great. So I'm going to use Dropbox here, and it's going to ask me for authorization. And it says Windows Azure is going to create a folder in your Dropbox, which sounds pretty scary, but it's okay. And yeah, and then it just asks which folder would you like to use, and that's just also fine. Alrighty, so now we have the website being created. In the background, I'm just going to take this hello node file. I'm going to rename it, actually make a copy called app.js or server.js, because that's what Azure expects. And then I'm just going to move that app.js file to my Dropbox, apps, Azure, hello vs live node folder. And now, and that's kind of annoying, I have to go to my newly created website, which is being created, and tell it to sync from Dropbox. This is a weird design decision, but actually it could kind of make sense. You don't want every accidental edit to end up in production. So you have to tell Azure, I want to sync the changes from my repository. So I'm going to deployments over here, and there's one active deployment, which is empty. And then I'm going to hit sync, and yes, and a couple of seconds later, I'm going to see another deployment in here, and maybe 5 seconds after that, we'll have the website up and running, or so I hope. Let's see. Yes, deployments. Deployment, please show up. In the meantime, I can open the website. Hello vs live node Azure websites.net was the URL. And well, here it is. So we have just published the Node application to Azure without actually bothering to set up even the most basic of source controls. We just used Dropbox for the deployment process. Okay, well, that was kind of manual, and the next thing I'm going to show you is deploying a website from the command line, which means you can make it part of your build process to push to staging, to push to a QA environment. You can create, provision, and deploy websites from the command line. But before we do that, let's talk about a couple of more Node concepts. So this was a very, very, very simple application, and I wouldn't be using something like that for the whole talk. So let's take a look at something a bit more complex. This here is Express. This is yet another Node module, which is an MVC framework. It should be pretty familiar if you're working with ASP.NET MVC. There's controllers and views, and there's a template engine, so you don't write plain HTML. You have this template language in which you specify strings and loops in your HTML code, and they get populated by the model, by the controller. And in this case, there's also hooks which specify how to get to different parts of your application. So for example, I can say, when the user issues a GET request to the URL hello, I'm going to get the request, and I'm going to send back the file hello HTML. These extensions are part of Express. Another example here is post. If the user posts something to the echo URL, I'm going to take that request, I'm going to parse the body, and it's automatically parsed as a JSON object if the content type is application JSON, and then I can just access it dynamically in my response. And I'm sending back you said and whatever message I got as the body of that request. And then finally, I have to say, yeah, I'm listening on a particular port. So this is a very basic Express application, and we're going to use something like that soon in a kind of chat room application where we can see messages from different users and post new messages ourselves. And it's going to be pretty similar to this in terms of the different moving parts. And the one final thing I need before I can show you the whole app and deploy it to Azure is a module called nstore. And this is a third-party module. It's not really very well supported, but it's very good for this demo because it is a database in a single JSON file. So it's really easy for development, for testing purposes, very easy to verify that your database is working properly. You just basically have this single JSON file and you have a module that manipulates that. So nstore, you just require it, and then you have a bunch of options for manipulating the database, like maybe you want to save a new object in that database, and that takes a key, an object, and a callback that says if the operation succeeded. And you have an all method which just lists all the objects in your database. and you have a find method which searches the database for objects that have a particular property. Now there's no indexes in here, it's just a flat JSON file. But it's really, really easy to prototype things using Ansible. So now it's time to actually deploy an application to Azure websites. And so before we do that, I'd like to say a few words about the options you have. So as you have seen, you have deployment options with Git, Mercurial, which is relatively new, TFS, FTP, if you really insist. So yeah, you could just FTP your JavaScript files to Windows Azure. You can use Web Deploy, which is what IIS uses, and you can use Dropbox. Now, with everything here except FTP, you get automatic rollback. So all the deployments are saved somewhere, and you can just say, oh, well, I don't like this deployment, let's roll back to a successful deployment I had maybe 5 days ago. And that, again, works for Dropbox, works for the various source control solutions. You get this automatic rollback for free. If you want to use any modules, and Express is not a good example, HTTP is not a good example, it's built in, but Express and NStore are not built in. So if you want to use any external packages, you specify the dependencies you have in a file called package.json. So instead of just copying the binaries to the server yourself, you tell the server, you tell Azure websites, here are my dependencies, just go and find them when you need to deploy the website. And that means you push only a tiny bit of JavaScript to the server, and it goes and downloads maybe tens of megabytes of additional modules required to support your application. And there's an additional benefit to this. Some Node modules are cross-platform, but they can be compiled to native code for a particular platform. So they have this cross-platform JavaScript layer, but they also give you C files or C++ files and a make file. And they tell you, you could use the JavaScript files which are cross-platform, or if you want the performance, you can compile the C or C++ sources to a native binary for that platform. And that also happens during the deployment process. So if you're using a Mac, you have your own native Mac version of this module, and if you're pushing it to Windows Azure will download, compile, and deploy the native Windows version of that module. And again, hopefully, if the source is cross-platform, the testing process is going to be easy as well. And finally, debugging is really, really easy with Windows Azure websites. I've just been in Eric's talk like a half hour ago, and he was talking about debugging web services, cloud services on Windows Azure. And these were .NET cloud services. Well, to debug Azure websites, you literally can have a debugger with breakpoints and source code support running in your browser, debugging your production website. Now, I'm not saying I recommend debugging your production websites with breakpoints and source support and stepping through while the users are waiting, but you could do this if it's necessary. So you get full debugging support with breakpoints and everything in your browser, even if your website is running in kind of a production mode. So let's just start with a simple application. It's right here, called, there's the main file, app.js. And maybe before we look at app.js, let's take a look at the package.json file, which has my dependencies in it. So these are my dependencies. This is the package.json file. I'm specifying all the modules I depend on, and I can specify particular versions on which I depend. Or I could say, well, just give me whatever you have that's greater than or equal to 001, which is the lowest version number you could have. So if I know there's some breaking changes in my future, I could just stay with a particular version I support, or I could just say, well, download whatever you have that's newest and available. And by the way, using this mechanism, I can even choose the node runtime to use. I can say, I want a node version that's greater than or equal to something, or I could say, node changes occasionally, so I just want a particular version of node with which I've tested my app. And that's perfectly fine and works as well. So with this package.json, let's take a look at the app itself. So the app itself has a couple of routes which use Express. I have the get of the root, and here I'm just enumerating all the messages in my database, which is currently just a single flat JSON file. And if everything went well, I'm issuing this render directive here, which is kind of similar to the ASP.NET View method. which you have in your controllers, where you pass in some properties from your model, and then the controller renders the view. So here I'm rendering a view called messages.jade, and Jade is the default template engine used by Express, kind of similar to Razor, except it's not really similar to Razor. I'm passing in an object, which is my model, and here I have a page title, which arguably doesn't belong in the model, but anyway, and the messages themselves. And, well, if you're curious about messages.jade, here it is. It's kind of HTML, but it's much cleaner, right? I mean, you don't have to specify closing tags. There's no less than and greater than signs. It's much cleaner, and the indentation matters, of course. So whenever I indent something, it means it's going to be inside, nested in the previous element. And I can run loops in here. So I can say for each object that comes from my model, passed in by the controller, I'm going to write a row in a table. And finally, I also have a post here, handling post to the new message builder. And here I just create a new message populated with data from the request body, which again was parsed for me automatically. I didn't have to do anything for this. And then I issue a log statement here, which will be important as we read these logs from Windows Azure. It's going to be very easy to do that as well. And finally, I save that to a local store. And when that succeeds, I redirect the user to the root. And there's also this line here, IO sockets emit. And I didn't really intend to focus on this, but basically socket.io is a module that gives you WebSockets support with Express. And if WebSockets are not available in the browser your users happen to be using, it falls back to other things like forever frames, polling, and various other alternatives. So it's basically WebSockets that work even if you don't have WebSockets. And what it allows me to do is, without refreshing the page, I can push to other users a notification when new messages appear in my messages database. So let's take this website and run it locally for a moment. I'm going to cd here and run node app. And it's running now. And I can go to my browser. And localhost 2013 gives me this amazing UI. I'm not a designer, as you can clearly see here, but I did my best. And well, I can put my username in here. Hello, Visual Studio Live, post message. And in this local version, I now have to refresh. And then the message shows up. And if I go back to the command line, here's the database. And if I just cut that, here's the database. It's just, like I said, a flat JSON file. Not very suitable for production applications, but very good for development. Okay, let's push this app to Azure. And this time, let's do it from the command line. So, you can download something called the Azure Cross-Platform Command Line Library, whatever, and install it on your Windows machine. And that in itself is a Node application. Even though you use it to manage virtual machines, to manage service bus notification hubs, you manage all Azure services with it, and it's based on Node.js. And here's what it looks like. I just type Azure in here, and there's some beautiful ASCII art on the top. Yeah, seriously. And and there's a bunch of commands that I can use. And what I'm going to do now is Azure Site Create, which creates a website. And I'm going to say I want to use Git as my repository, as my source control solution. Need a site name, it says. VBS, VS Live. Where do you want that app? Where do you want that website? The locations we have, well, let's go with West US. Creating the website, and it's also going to initialize a local Git repository for me, and it's going to link that local repository to a hosted repository that Azure created for me. So now I can push my changes to Azure. Okay, well, currently I have nothing staged for a commit. Oh, sure. Oh, I shouldn't have done that. Okay, sorry. Let me just delete this website for a second, which I also can do from the command line. And the reason I'm doing this is that I have a local repository already, which I have to delete first. And yeah, sorry. Now let's go ahead and create that website again, BBS VS Live. And let's go with REST.js again. And now Git is going to show that no changes are currently in progress. And I'll have to tell Git which files I want to commit, and then push it to the remote. So currently we have nothing tracked, but there's a bunch of new files from Git's perspective. And I'm going to just say git add everything. And I'm going to do commit, initial commit. And finally, I'm going to do git push Azure master. And I input my password here. And it's going to push this website to Azure websites. And the modules are going to be downloaded on the Azure end. And we're going to see a bunch of log output now for all the modules as they're being downloaded by Azure. So here they go. As you can see, this really tiny, simple application depends on a lot of external functionality. Express itself is a pretty sophisticated framework, and there's a bunch of dependencies there. Socket.io is pretty sophisticated, and there's a native version of it that's going to be compiled on the Azure side. So while this is running, I'll just go back to the portal, and I'm going to just show you this website here. It was created successfully, and in the deployment section, I probably should see that there's currently a deployment being processed. And this is the deployment we triggered by pushing my changes from the local repo to the remote. And it's running the deployment command, and it's done. Nice. So this is now active, and on the command line I also get success output. And now I can just go to BBS VS Live Azure Websites.net, or I can try. Let's see. BBS VS Live Azure Websites.net. That page is not available. That's not very good. Let's try a different browser. Yeah. And if it doesn't work, I have a video which I can show you. No, I'm serious. Okay, let's just do that. It's working for you? Okay, that's interesting, definitely. Maybe a DNS issue. Anyway, if it's a DNS issue, then I could probably find the IP address somewhere here, or maybe not. Nah. Oh, well, whatever. I'm just going to show you a video. Right, so let me just, yeah, this shows me doing the deployment. Lovely. And then the app itself looks like this. So I'm just, yeah, navigating to that URL. And it's loading. And if it's working for you, then this is probably what you should see. And then I can post a message in there and refresh, and it's there. Yeah. So we have our website on Azure, and probably the reason I'm not seeing it in UR is that I have the IP resolved to something that doesn't exist anymore, and I'm waiting for the cache to clear, and I'm not going to waste your time by now clearing the cache. But if you want, you can just go to bbs-vslive Azure Websites.net, and you're supposed to see this beautiful bulletin board, functional and work. Okay, so we have successfully deployed an Azure website from Git, from a command line, but what about this debugging experience that I've been promising to show you? So what I've done is actually cheated a bit. I've added a couple of files which you wouldn't typically add to your Node application unless you were planning on deploying it to Azure websites. One of them is called iasnode.yml. And this file defines the interactions between IAS, which Azure Websites happens to be using, and the Node.exe process. And IAS Node is actually a fine piece of software that is also open source. And right here I have a couple of settings, and the most important one is here, debugging enabled. And this means that I can now debug the app as it's running in production. The other file I had to push is webconfig. And this you should be familiar with. Here I have just a simple rewrite rule that says specific requests that have to do with debugging my Node application should not go to the Node process. They should not be handled by the application itself. They should be handled by something called Node Inspector, which is the debugger that we're going to use. And so the way it works, if I append /debug to any of my URLs on the JavaScript files, I'm going to get a Node Inspector view. So another thing I've done here is added this logging enabled switch, which lets me see after the fact and as a stream all the log messages that my application has generated. And so if I just go back to the command line here, I can now do Azure site log tail. And if any of you can post a new message at this time, we're supposed to see a trace statement appear in my console. Could any of you do that, please? Wonderful. So this message here was generated by a console.log statement on the server side and streamed live into my console session. So this is as live as it gets. You can see a stream of the log messages your application is printing. And again, there's debugging support here, which would require the website to work for me, and I'm not going to spend any more time on that. So this was Azure Websites, and the database, yes?
Can you go back to the previous screen? Bill's posted both of these, and no, it's not the same ID. It's almost the same ID class.
The IDs are not the same.
Almost except on the left.
Yeah, I'm using a module for that called Node.js, which generates these IDs for me. I have not explored the way it generates them.
Okay.
But it's open source, so you can check. Okay, so the database here is really not something you could use, so let's move on to changing the data access layer to use something more reliable. And what's more reliable than SQL Server, right? So we're going to use a module for that called MS-Node SQL. This module is open source, it's provided by Microsoft, but it's not cross-platform. It relies on the SQL Server native client, which I've mentioned before. So you can't use it on anything but Windows. On the other hand, Azure Websites runs Windows, Windows Server 2012 to be specific, and so I can use MS-Node SQL there. Now it has only very, very basic support for database operations. It's by no means an ORM. It's got two methods, query and query row. Now you use query for queries, and you use query row for everything else, like inserts, deletes, DML statements. Yeah, so it does need an ORM layer on top, probably. But basically what I'm going to do is just replace wherever I've used this nstore module with functions from MS-Node SQL. Okay, so let's switch to my Windows virtual machine. And on my Windows virtual machine, which is now adapting to the new display resolution, I have another instance of Sublime with the SQL Server version of this Node application. So basically the difference is that I now rely on MS-Node SQL, and I have this long connection string here, which was provided to me by SQL database, the SQL Server in the cloud, the hosted SQL Server. And my password is in that connection string, so I'm not going to scroll all the way to the right. And then I just changed the get and post functions here. So when a get is issued, I just select user and message from some table. And when the new message request is posted, I create a new object and I insert that into the table using an insert statement. And again, this really needs an ORM on top. Particularly, this insert here is subject to SQL injection because I just concatenate query parameters. So I'm not going to push this to SQL, to Azure Websites and make it accessible to the whole world. Instead, I'm going to demonstrate something more interesting, which is that this Node app can run locally inside my virtual machine right here and access a SQL Server database which is hosted in Windows Azure. So if I just go to this folder, and again I type node app, and this is Windows now, right? And it's just working. And I go to my browser here, and navigate to localhost 8080. Then we get a bunch of data that's already in my SQL database. And I was testing it during Scott's keynote in the morning, so you can see it's fresh, right? And I haven't cheated. And we could also put a new message in here, hello again. And it refreshes, and it's right there. And it's actually making changes to a SQL database that's hosted in Azure. And in the portal, if I just relog in, really need to use shorter passwords, I can not load the required part of the portal. Okay, let's see again. Okay, so this is the portal, and we need specifically the SQL databases, which are right here. And I've got a database here called BBSDB. And if I click Manage right here, it's going to open something resembling SQL Server Management Studio. Right? And it's going to ask me for my username and password. So I'm going to type in the username. The password I obviously do not remember, but I'm going to just copy it from here to here. There's nothing production-like running in that database anyway. Once it's connected, you can see this is, by the way, a Silverlight application. And I can design my database from here. I can go to the Design tab. Here's my table called Message. Click Edit, and then click Data. And here are the messages that we've seen. So it's actually going into a SQL Server database in the cloud. And I can make changes, of course, visualize my database, indexes, keys, whatever. And by the way, you could also use SQL Server Management Studio. It's not like you can't use it. There's just this lighter experience that you have inside the browser. Okay. So that was MS Node SQL and the SQL database. Right? I just created a SQL database in Windows Azure. I got this magic connection string from there with this seemingly random server name and password. And then the other thing I had to do, which I did not show you now, is open the firewall. By default, and that kind of makes sense, SQL Azure will not just allow random connections from random locations around the world. So when you first open the portal and manage your SQL database, it will tell you, hey, do you want to add the IP address you're connecting from to the firewall rules for that SQL Azure instance? And that works well for development. In production, you'll have to configure access from the outside so that your on-premise Node application can access that SQL Server database if that's the setup you're looking for. Now, here's a slight intermission. Windows Azure Mobile Services, which, like I said, I'm really also excited about, and on Thursday I'm going to give a talk about here as well. Azure Mobile Services also relies on a SQL Server database. So wouldn't it be awesome if I could just share that same SQL Server database with my mobile service front end on the one end and the Node application you've just seen on the other end? So I'm not going to show you any code right now. I'm just going to show you a Windows 8 application that accesses the same database. So here's the start screen. Here's the application. I have not worked very hard on the splash screen. And inside that application, you can already see the messages from that SQL Azure database. And unlike the Node application, this runs on the client, and obviously it doesn't connect directly to the SQL Server database. That would be a pretty horrible idea for an internet kind of application. So it's using a backend layer called Windows Azure Mobile Services. It just happens to reuse the same database. And I also get push notifications from this. So if I post a new message here, hello from Windows 8 app, I'm going to get this nice toast right here This was real time. The moment I hit post message, I got a toast notification from the server telling me new data has been added. And so this Windows 8 application can really be used as a kind of primitive chat client. There's only one chat room, and everyone sees all the messages, and there's nowhere to say what the username is. It just kind of assumes the username is Sasha. But other than that, it's a fully functional chat client, right? Okay. Yeah, that's the recording. I better keep it here. Okay, let's move on. So that was Azure Mobile Services, just a quick taste of what it can do. And now we're going to replace that data storage layer with something a bit more costly, a bit cheaper. Azure Table Storage is a NoSQL solution, which is very suitable for the kind of data I'm storing in my database. Because essentially, I have a SQL Server database with one table and 3 columns maybe. User, message, timestamp, ID, and I'm not doing any sophisticated indexing, I'm not doing any sophisticated queries, and I'm paying for a SQL Server instance, which is like $2 an hour. Like the cheapest one is about $2 an hour. Table storage, on the other hand, is pennies for a huge amount of data, for gigs of data. And the transactions are very cheap, and there's no virtual machines that you have to think about, there's no scaling involved, it just scales automatically. So I'm not going to explain everything there is about table storage, but in situations like this, when I have a huge amount of data, but it's very simple, this solution really should be considered before you use something relational like SQL Server, Oracle, maybe even heavier solutions. So there's a Node module for that. There's a Node module for accessing Azure Table Storage. You can create tables, you can insert objects into tables, you can enumerate objects in your tables, and it's really easy for me, again, to just go back to the app.js file and replace the data access layer with table storage. In my case, because I only had this one table. So, the table storage version is right here. And you'll notice here, my app actually requires the Azure module. And this is provided by Microsoft, but again, it's open source. It's a Node module that you can use freely on all platforms. This is not Windows specific anymore. And the reason is that table storage is just a RESTful API. It's a bunch of endpoints, HTTPS endpoints, which you can post new objects to, query objects. It uses OData for filtering and stuff like that. And so I have here my account name and account key. Again, the secret's in the open here. And here I'm creating a table called messages in case it doesn't exist yet. So the first one is going to initialize whatever is necessary. And then you see the familiar get and post function calls. And in the get case, I'm using something called Azure Table Query Select. And I'm saying which table to use. I don't use any filters here, so I just say query entities. And it's going to asynchronously bring back all the entities in that table. And when necessary, I insert a new entity which has my model data, user and text, for the message, but it's also got a couple of columns that are required by table storage, and these are the partition key and row key. And again, I'm not going to go into what exactly this partition key and row key mean, but basically it's a way to index your data for faster queries, so you can search for data with a particular row key very quickly. And the partition key is a way of partitioning your data, as you might expect. So, for instance, if the partition key is the same, you can use transactions on multiple entities, like maybe change multiple messages if they're by the same user. So I could use the username as the partition key. So there's a couple of new concepts here, but basically it was just, again, quite a slight change, and I'm still using Node. It's still all very Node-like, right? The APIs are very Node-like. And again, I'm going to use this app on premises. So I'm going to switch to the right folder, and I'm going to do Node app again. This time it's running locally, but it's connecting to a table storage account in Windows Azure. And in my browser here, I can now go to localhost 2013. And this, it looks the same, but the data is different. This is coming from Azure Table Storage. And again, I can just insert a new message here. This one does not refresh unless I refresh. And you'll just have to take my word for that. It's actually changing something in Azure Table Storage. The reason you have to take my word for that is that the portal, the Azure portal, doesn't give you a very easy way of inspecting your tables. There's support for this in Visual Studio. There's this Cerebrata thing that you've seen in the previous talk maybe. There's even an online tool that can inspect your table storage, but these are all third-party solutions, so I'm just gonna work with that. So this was table storage, a NoSQL solution that you can use from your Node applications. And by the way, Azure Storage also has additional concepts, two additional concepts, which are queues, used for communication between components, and you can use them from Node, and blobs, which are just files. And you can use these from Node as well. So it's all wrapped very nicely by the Azure module, which gives you access to all those storage facilities that Windows Azure currently has. Yes?
The table that's being used here, is this a standard table such as Cassandra or something like that, or is this one that Microsoft has designed on its own?
The table is just a bunch of properties that your object has.
There's some standard ones, like HBase and so on. Is Microsoft using the standardized ones, or is this one that they...
Oh, you mean the actual storage solution behind the tables? No, it's proprietary. Okay. And the final thing I want to show you today is using Node in a virtual machine that I created. No more websites, no more hosted services. We're going infrastructure as a service now. So I want to run Node on my own virtual machine. And the made-up reason I have for this is that Linux is cheaper, right? I don't have to pay for Windows licensing costs. And I want to run MongoDB, which actually can run on Windows, but it's kind of more popular to run MongoDB on Linux. So I went ahead and created an Ubuntu virtual machine. And it's really cheap to use. It's a small instance. And as you may have heard in Scott's keynote today, stopped virtual machines do not incur any cost anymore. So I can just fire up the virtual machine whenever I have to give a talk and demo Node on Ubuntu. And specifically, I'm going to use a very nice module that wraps MongoDB called Mongoose. And that's an ORM for MongoDB. MongoDB, again, in and of itself, is a huge framework, platform database. It's a NoSQL database, again. It's more kind of an object database rather than just a standard table database. But again, it doesn't really matter. There's a Node module that wraps it very nicely. And it would work very well with the simple data format that we have. So I just changed the data access layer for the third time. This time, I'm using Mongoose as my backing layer. So here's the code. It's right here in BBS VM. By the way, you'll get the source code later, and you can compare these solutions. I've only changed the JavaScript file. Of course, the views, the models, they're all the same. Only the actual data access layer had to change. So this time I'm requiring Mongoose, which is this ORM for MongoDB. And I'm creating a connection to it when we fire up the application. And here I'm using localhost. So I'm connecting to a database that's running on the same machine as my Node application. But as I mentioned before, there are some partners that give you hosted MongoDB instances, so you don't have to care about the virtual machine running MongoDB. You only care about your Node application. They can scale your Mongo instances and stuff like that. Of course, they provide reliability, SLA. Anyway, I'm just running my own MongoDB instance. And then again, we have get and post. Get uses message.find, which is provided by Mongoose, and again, I'm just retrieving all the messages there are in our database. And post creates a new message object with a unique ID, user and text, and saves it using the save method that goes into Mongoose. So again, everything here is asynchronous. As soon as that save completes, I either have an error, which I return, or everything was fine, and then I use socket.io to emit the notification. Okay, well, where's the virtual machine? So going back to the portal, for some reason I was logged out already. So going back to the portal, there's of course a virtual machines section in here. So let's just find that virtual machines section right here on the left. Virtual machines. Get out of here. Virtual machines. Right. So I have 3 virtual machines. One of them is running Ubuntu. The other 2 are Windows servers. This is the Ubuntu one. And it's got a couple of endpoints here. I'm going to use SSH to connect to that Ubuntu VM, but I also have endpoints for ports 80 and 8080. And you have to specify these explicitly when you're working with virtual machines, because by default, nothing is open. And in fact, you can lock yourself out. You can create a virtual machine with no ports open, and then there's no way for you to connect to it at all, unless you go here and configure something in the firewall. Now, when you create a Linux virtual machine, you get SSH enabled by default. When you create a Windows virtual machine, you get remote desktop enabled by default. So you can always connect and start managing your virtual machine. Okay, so let's SSH into that nice VM. It's already online, and it's called sasha-ubuntu.cloudapp.net. And my username is Sasha. And I have some password here, and we're inside. So welcome to Ubuntu 12.04, and let's ls here. So that's what I have in my root. And there's this BBS folder here, which already has the application I've just shown you. So inside this BBS folder, we have the familiar app.js, package.json, a bunch of files, scripts, and modules. Now, by the way, I didn't have to pull all the Node modules, even though I'm not using Azure websites anymore. I just copied this package.json file over here, and then I could do npm install, and it just went to the package repository and grabbed all those modules for me. Again, it's just using this JSON file which describes my dependencies, and other than that, I didn't have to push any dependencies to my VM. So anyway, now I can just use Node app, but before I do that, let me actually show you there's a Mongo instance running here. So let's start by grepping for Mongo. So yeah, I have MongoD running here in the background, and that's the database itself. And I can connect to it using the Mongo client application. And now I can do things like show collections. And it says, yeah, you have a collection called messages. And now I can do messages, db messages.find. And it tells me that I have 2 messages right now in my database. These are some testing, from some testing I've done earlier. But now let's expose this thing to the internet. Node app. And now it's running on port 8080. So if I go to, and you can do this too, Sasha Ubuntu cloudapp.net 8080, you should see this bulletin board application, this time based on Mongoose. So here it is, different messages again. And I'm going to post a new message, Sasha, hello from live session, right, and here it is. And again, thanks to socket.io, I just get this live, and thank you, Jay, for posting another message. Right? So I'm probably going to take this VM down in a couple of minutes, but in the meantime, you're welcome to experiment with it. So that was Node accessing MongoDB on Ubuntu. Other than the logo, there's nothing Microsoft about this, right? Absolutely nothing. The virtual machine is mine, it's Ubuntu, MongoDB is not Microsoft at all. Node is cross-platform, so you can run anything you want on Windows Azure, really. And this is something I'm very happy about, even though I like Windows, I like .NET, I like C#, but I also like options. Right? Okay, so one last thing. I've been using Sublime Text, which is a great editor. I'm sure some of you working in front-end development love it. But there's a better option in many ways, on Windows at least, called Web Matrix. And there's a talk on Thursday, so I'm not going to ruin the surprises for you, that's focused entirely on Web Matrix. But basically, it's a free integrated development environment for web applications of any kind. It has support for PHP, for Python. It has support for Node as well. And so on Windows, you really should consider using Web Matrix because it's also integrated with Windows Azure. So you can create a new website from within your IDE. You can deploy, you can manage deployments, and it supports Node with IntelliSense, which I can't say about Sublime Text, which is the editor I'm using. So it's a really easy way to get started, and Web Matrix 3 is the latest release. It's really kind of new, maybe 2-month old, and it's got great support for Windows Azure and for Node.